We'll now look at the calculus version of the mean value theorem. So in general, whenever we want to find the mean of a set of numbers, we would add them up and then divide by the total number of things there are. Here it's a little more complicated since we're looking at an entire interval. Since we're looking at an entire interval, if we want to add things up, instead that would be an integral from a to b. And then we want to divide by the number of things there are. Well, in this case, that's going to be the length of the interval. So in general, the average value on the interval a to b is given by 1 over b minus a times the integral from a to b of f of x dx. And this is how we find the average value of a function. For example, I have this function 3x squared plus 9 over the interval negative 3 to 1. So we start with finding the length of the integral, b minus a. Then we do the integral from a to b of f of x dx. So this is 1/4 times, I add 1 to the exponent and divide to get x cubed plus 9x. And this should be evaluated between negative 3 and 1. So I have 1/4 times 1 cubed plus 9 times 1 minus negative 3 cubed plus 9 times negative 3. And when you work this out, you get 16. We'll do another example. This time we're going over the interval from negative 1 to 2. So I have 1 over b minus a times the integral from a to b of f of x dx. So this is 1/3 times. I add 1 to the exponent and then divide by that number, and then plus 2x, going between negative 1 and 2. So that gives me 1/3 times 1/4 times 2 to the 4th plus 2 times 2 minus 1/4 times negative 1 to the 4th plus 2 times negative 1. And when you work all of this out, you get 13 over 4. So the average value over this interval is 13 over 4. So our mean value theorem says if f is a continuous function on the interval a to b, then there is a point C in this interval such that f of c is equal to the average value. So basically what this is saying is the average value is actually going to be hit at a particular point. We won't skip over it, but there will actually be a point in this interval that passes through the average value. For example, we looked at this function, 3x squared plus 9 over the interval negative 3 to 1, and we found that the average value was 16. So there is some point in the interval negative 3 to 1 where this function actually hits the point 16. So we can set the function equal. Subtracting 9 from both sides gives me 7. we can divide by 3 and then take the square root. So we have plus or minus the square root of 7 over 3, which is approximately plus or minus 1.527. Now you'll notice only one of these is actually in this interval, negative 1.527. However, there is a point in the interval that this function actually reaches its average value. We also looked at this function and found that the average value was 13 over 4. If we set this equal to the function, we can subtract 2 to get 5 over 4 is equal to x cubed. Take the cube root of both sides. And this is approximately 1.077. So once again, we can see this value is in the interval. So we do actually reach the average value in this interval.